A vision, both audacious and otherworldly, rises from the earth. Its iconic, star-shaped canopy, an architectural marvel, seems to defy the very laws of conventional construction. This is not a digital rendering, nor a distant dream. It is a genuine airport terminal, a tangible monument to human ambition, born from a landscape of barren wheatfields in 2014, transforming into the world's largest single terminal by 2019. This is the story of how the impossible became real. In its nascent stages, the site was nothing more than raw, untamed dirt. Yet, in less than 5 years, it was destined to become a sprawling hub of global travel. The deadline was immutable, tied irrevocably to a national anniversary. 4 years and 9 months. There would be no extensions, no concessions to the monumental challenges that lay ahead. Before the first shovel could break ground, a silent, unseen migration unfolded. 20,000 people, their lives intertwined with the land, were respectfully relocated. It was a logistical feat in itself, a testament to the sheer scale of the project, long before any concrete was poured. The ground itself, however, held a formidable secret. This was not merely a matter of laying foundations on stable earth. The soil harbored a critical flaw: differential settlement. One vast corner of the proposed structure threatened to sink faster than the rest, a geological imbalance capable of tearing apart anything built upon it. Dozens of pile rigs clawed at the earth simultaneously, a relentless symphony of machinery. But the true battle lay not just in driving piles, but in the meticulous, almost obsessive verification of every single one. The solution to stability lay deep beneath the surface. 2 full levels were excavated and constructed underground first, a foundational labyrinth designed to anchor the colossal structure. This was the only possible option, a strategic retreat into the earth to secure the future above. The decision to build one sprawling, interconnected terminal rather than several smaller, more manageable structures was a declaration of architectural intent. Yet, this singular choice also became the genesis of every subsequent engineering battle, multiplying the complexities exponentially. From day one, groundwater proved a relentless adversary. Hundreds of wells ran ceaselessly, pumping millions of liters, holding back the subterranean deluge that threatened to engulf the nascent foundations. This was a problem of unprecedented scale, one that had never been solved with such magnitude before. The very sequence of construction itself, the concrete slabs, vast and monolithic, presented a paradox. They possessed the terrifying ability to crack themselves even without a single load pressing upon them. This internal stress, a silent killer of structural integrity, demanded an audacious solution. Engineers made a wild, counterintuitive decision: leave deliberate, unfilled gaps across the entire floor. These strategic voids remained empty for months, a testament to patience and precision. Fill them too soon, and the floor would fracture. But the engineers had a secret weapon: a specialized concrete mix engineered to resist its own inherent shrinkage. This was not a single defense, but a multi-layered strategy. 3 separate, interlocking defenses against one pervasive problem. No solitary solution was deemed sufficient. To combat this internal warfare, they reached beyond conventional wisdom, adapting techniques typically reserved for earthquake-resistant structures. Seismic isolation principles were applied to manage the concrete's own expansive stresses, a radical cross-pollination of disciplines. While this intricate dance of concrete and earth unfolded above, an entirely separate railway system was being constructed directly underneath the terminal. Simultaneously, 2.5 million square meters of underground piping were laid, creating a vast geothermal network. The building would literally heat itself from the earth, a testament to sustainable design. Beyond its immediate footprint, 2.8 million cubic meters of artificial wetlands were meticulously crafted, not just for aesthetics, but as a vital, proactive flood prevention system, ensuring resilience long before the first aircraft ever touched down. The roof, that iconic starfish, is supported by 8 massive curved columns. Yet not a single one stands straight. Some might question this aesthetic choice, but the curves were not merely decorative. They were a structural imperative. Straight columns under the immense, complex loads of this unique roof would have failed. The elegant arcs were the only geometry capable of distributing the forces, a dance between form and function dictated by physics itself. Every formwork panel used for these columns was uniquely shaped, a bespoke piece of a colossal puzzle. This level of precision was unforgiving. Place one rebar bar incorrectly within that curve, and it would be locked permanently into the concrete, an irreversible error. Before a single beam was built, 420 load scenarios were exhaustively tested. Wind, snow, seismic activity, and extreme heat. The structure incorporated 38 different beam sizes across 170,000 individual members. The drive for material efficiency, saving steel wherever possible, made fabrication enormously harder. 170,000 pieces, with very few identical, each had to match perfectly on site. The delivery order, a logistical ballet of unprecedented complexity, had to precisely mirror the installation order. This is the hidden story of the starfish. Not just a building, but a triumph of engineering, a testament to an unwavering will to transform a dream into a concrete reality, rising from the earth against all odds. The unforgiving reality of monumental construction begins with a single, irreversible truth. A wrong order, a misstep in sequence, and everything stops dead. This is not merely a delay, it is the silent, catastrophic unraveling of months, even years, of meticulous planning. Build a structure of this scale in the incorrect sequence, and its nascent sections, still vulnerable, will deform under their own weight, long before the grand design can even begin to take shape. The very materials themselves, steel and concrete, become witnesses to their own slow, agonizing failure. The initial roof section, a colossal piece of engineered artistry, rose into the sky as one unified mass. It was a moment of breathtaking audacity, a testament to human ingenuity against the relentless pull of gravity. Yet this was just the beginning. 25 more operations, each demanding the same flawless execution, still lay ahead. For every single one of those 26 lifts, the precise position of every crane, the arc of its swing, the exact trajectory of its ascent, was calculated with a precision that bordered on the obsessive. A fraction of an inch out of alignment, a whisper of a wrong position, and the massive steel would not just settle, it would twist, warp, and deform, irrevocably compromising the integrity of the entire structure. 13 sections of this sprawling canopy were meticulously assembled, piece by intricate piece, at their full, dizzying height. Each connection, every bolt, every weld, underwent a rigorous, almost sacred inspection before the next phase could even be contemplated. The very steel, a living entity within this construction, was monitored 24 hours a day, a constant digital heartbeat tracked throughout the entire assembly process. A single, unexpected movement, a tremor in the data, was enough to bring the entire operation to an immediate, grinding halt. 31 pivotal moments marked the final connection of two sections, transforming disparate components into a unified whole. Each of these critical junctions was timed with excruciating precision, guided by live deformation data streams that revealed the microscopic stresses and strains within the metal. Then came the delicate dance of removing the temporary supports, a slow, agonizing process monitored relentlessly. Any unexpected shift, any tremor beyond the predicted, and the removal ceased instantly. The stakes were too high. the consequences of miscalculation too severe. To understand the boundaries of failure, the engineers embarked on a brutal yet essential experiment. They constructed a tiny, perfect replica of the roof, then subjected it to an engineered catastrophe, shaking it with the force of a simulated earthquake. They watched it fail. They needed to know if the collapse would be sudden, instantaneous, offering no warning, or if it would be a gradual surrender, a slow deformation measured in precious seconds. The test confirmed the latter, a crucial piece of knowledge. This massive structure, if ever compromised, would not simply vanish into dust. It would signal its distress, buying invaluable moments. Yet even with that knowledge, the steel canopy, suspended high above, could not yet hold itself. Remove its temporary support too early, and it would deform permanently, a silent, costly scar on the face of the project. The entire endeavor hinged on one final connection. After that moment, dozens of isolated, vulnerable pieces would coalesce, transforming into one unified, self-supporting roof. 2.5 years into this monumental undertaking, for the very first time, the distinctive starfish shape of the terminal began to emerge against the sky, a breathtaking realization of a visionary design. 180 meters. That was the staggering distance between supports in a single span of the roof, an architectural leap of faith. The minute deflection, the subtle sag inherent in such a vast expanse, had to be calculated with absolute, unwavering precision. Now, the time arrived for the glass, a skin of transparency to enclose the structure. But this was no ordinary glazing. Almost none of the panels shared the same shape, each a unique tessellation designed to fit the complex curves. Then, a problem emerged that no one had anticipated, a challenge born from the very dynamism of the structure itself. This vast, curved roof, a living entity of steel and glass, would expand and contract by a remarkable 60 degrees between the depths of winter and the peak of summer. The engineers had to devise a system that allowed for this continuous, subtle movement without compromising the integrity of the glass or the structure. This was not a static marvel. It was a breathing, shifting organism. The skylights, those luminous apertures piercing the canopy, served a purpose far beyond mere illumination. They were designed as silent guides, an intuitive language embedded in the architecture itself, directing passengers through the sprawling terminal without the need for a single sign. From the central hub, 5 majestic arms extended outward, each one a repetition of the same intricate structural puzzle that had just been solved at the core. 79 gate positions, an entire city of departure and arrival, had to be fitted simultaneously across these 5 branching extensions, a logistical challenge so immense it demanded its own dedicated project management team. This terminal dared to defy convention. Nobody had ever before stacked departures directly above arrivals, a bold spatial innovation that maximized efficiency within a constrained footprint. This was precisely the decision made here, a testament to an unyielding commitment to redefine the passenger experience. Kilometers of conveyor belts, the unseen arteries of this complex, had to be threaded through a labyrinth of corridors, their pathways locked in months before the main construction even began. None of this intricate, vital infrastructure would ever appear in a glossy photograph, yet every single bit of it had to be completed flawlessly. Safety regulations mandated a maximum escape distance of 75 meters. This colossal structure, however, required a path of 200 meters, necessitating the construction of 29 dedicated staircases, each a lifeline in an emergency. Smoke, that unpredictable enemy, behaves differently in a space of such vast, open volume. A wrong airflow, an error in the sophisticated ventilation system, could transform an evacuation from an orderly process into a dangerous, chaotic struggle. 4 levels of the terminal were fitted out at once, a symphony of simultaneous construction. Daily logistics, the orchestration of thousands of workers, millions of components, and a relentless schedule, became nearly as complex as the foundational engineering itself. But perhaps the most unexpected detail, a touch of serene defiance amidst the steel and glass, was the decision to build real traditional gardens, living oases of green, sealed within the climate-controlled environment of the terminal. Even the solar panels, designed to harness the sun's energy, defied simple installation. Almost every single one required custom brackets, a bespoke solution for a bespoke roof. Nothing on this roof, from its grand spans to its smallest fixtures, was simple. Over 2,000 lighting drivers, an invisible network of intelligence, constantly respond to the changing daylight, automatically adjusting the terminal's illumination, creating a dynamic, energy-efficient dance of light throughout the day. This structure, born from 1,000 precise calculations and 1,000,000 individual efforts, stands as a testament to the fact that true architectural mastery is not just about vision. It is about the relentless pursuit of perfection, the courage to confront the unforgiving realities of physics, and the unwavering commitment to a sequence where one wrong order can truly stop everything dead. Within the heart of this colossal undertaking, a singular, intricate intelligence had to preside. Robots, advanced facial recognition systems, and automated baggage handlers were not merely components. They were envisioned as the seamless extensions of a living organism. Yet their individual brilliance remained inert, silent, until every single system could converse with every other, a symphony of data flowing through the digital veins of the structure. Imagine the sheer scale: 293 separate mobility systems, each a complex network designed to guide passengers with effortless precision. Among them, one moving walkway alone stretches for more than 90 meters, a silent river of motion beneath the soaring ceilings. Nearly 300 distinct systems, each with its own intricate purpose, were woven into the very fabric of the airport. And after installation, the true test began. Every single one demanded individual calibration, a painstaking process of fine-tuning and verification, ensuring flawless operation before the first passenger ever arrived. The vast majority, a staggering 98% of the materials and technologies, were forged within China itself. This commitment to domestic production necessitated an unprecedented logistical ballet, where supply chains moved with the unwavering rhythm of the construction schedule, each component arriving precisely when and where it was needed, a testament to meticulous planning on a scale rarely witnessed. Simultaneously, 4 runways were carved from the earth, rising in parallel alongside the terminal's majestic form. This was not merely another phase of building, it was an entirely different discipline, demanding a unique expertise distinct from the vertical ascent of the main structure. A runway, after all, is never just concrete poured upon the ground. Beneath its seemingly simple surface lies a marvel of civil engineering, a multi-layered tapestry designed to withstand unimaginable forces. For the first time in China's aviation history, this runway layout was conceived not around the available land, but meticulously sculpted to optimize actual flight paths, a radical departure from conventional design, prioritizing air traffic efficiency above all else. Most people traversing these vast expanses never consider the hidden intricacies. Yet, a profound hidden danger lurked beneath the surface. Even a millimeter of standing water on a runway can create hydroplaning conditions, turning a precisely engineered landing into a terrifying gamble. With the expectation of 300 takeoffs and landings every single hour, this threat was unacceptable. It demanded the largest automated air traffic control system ever conceived, a digital brain capable of orchestrating this constant aerial ballet with absolute certainty. Every single pavement light embedded in the runway surface had to be engineered to endure the daily, crushing weight of aircraft rolling directly over it, its beam angle remaining perfectly exact, unwavering in its guidance. A revolutionary tunnel was excavated directly beneath the runway itself, an ingenious solution, ensuring that no ground vehicle would ever have to cross the path of an aircraft above, eliminating a critical point of potential conflict and dramatically enhancing safety. Northern China's pervasive haze, a constant challenge to visibility, made advanced, low-visibility landing technology not merely an enhancement, but an absolute prerequisite from the very first day of design. There was no margin for error, no room for compromise. Then came the moment of truth. 4 years to the day after the first shovel broke ground, an Airbus A380, the behemoth of the skies, lifted off from runway pavement that had been finished, verified, and certified just in time. The runway, a triumph of human ingenuity and relentless effort, was finally completely open. On May 13, 2019, real aircraft touched down on calculations that, until that very moment, had existed only as abstract lines on a blueprint. The airport's operational heartbeat extended far beyond passenger terminals. Without fully functional cargo terminals and expansive maintenance hangars, airlines would be literally unable to depart, their vast fleets grounded. The railway beneath the airport, a high-speed artery connecting the heart of the city to this new aviation hub, had to prove its mettle. Its 19-minute journey across 41 kilometers was not just a convenience. It was a critical validation of the entire integrated transport vision. China's first omnidirectional runway layout, born from a vision to optimize flight paths rather than merely adapting to existing terrain, redefined the very concept of airport design. Every layer beneath the runway surface, invisible to the casual observer, had its own specific, crucial job, a silent testament to the depth of engineering thought. Above, 2,400 floodlights were strategically positioned, eliminating every conceivable shadow where ground crews meticulously worked on aircraft through the night, their safety paramount. The entire checkpoint system was designed to process 100 million passengers annually, a staggering figure demanding meticulous attention to every single detail, scaled to an unprecedented degree. Up to 50,000 workers toiled simultaneously on site, a moving city of humanity dedicated to a singular goal. Yet, across all 5 years of this monumental construction, not a single production safety accident was recorded. 0 accidents under such immense deadline pressure is not a matter of chance, but the direct result of relentless enforcement, an unyielding vigilance on every shift, every hour of every day. The sheer ambition of the project meant that 65 entirely new construction methods had to be invented on site. The existing engineering playbook, comprehensive as it was, simply did not contain the answers for challenges of this magnitude. Initial tests with 10 passengers moving through the system proved successful, but scaling that to hundreds per minute presented an entirely different problem, one that was rigorously tested, refined, and perfected. But even with all these triumphs, one final challenge remained. It was not a physical barrier, nor a technical flaw. It was the ultimate test of integration. To make this colossal, intricate machine, born of countless systems and endless innovation, feel utterly seamless, entirely effortless, a silent, efficient servant to the millions who would pass through its gates. To ensure that the sheer complexity of its creation would vanish, leaving behind only the simple, elegant experience of flight. The ambition was audacious. 2 monumental construction endeavors, each vast enough to stand alone, had to coalesce into a single, unified airport. A mere 12 months before its grand unveiling, the colossal structure finally received its name, a designation that only amplified the immense pressures still to come. The most arduous months of the entire project lay directly ahead, a relentless sprint towards an unforgiving deadline. Crucial decisions loomed. Which global carriers would anchor their operations within this new hub? Which would remain at the established capital airport? These were not mere logistical choices, but strategic maneuvers that would redefine air travel for an entire region. As the final phase roared to life, construction barriers, section by painstaking section, began to recede. For the very first time, the sprawling concrete as the final, unforgiving window to identify and rectify any flaw, any imperfection, before the eyes of the world turned to its global ceremony. Across its expansive apron, 2,400 floodlights blazed into existence, transforming night into an artificial day. Without this brilliant cascade of illumination, ground crews could not safely navigate the intricate dance around arriving and departing aircraft. Designed with a staggering long-term capacity for 100 million passengers annually, the immediate imperative was absolute. Every single checkpoint, every gate, every baggage carousel had to function flawlessly from day one. After nearly 5 years of relentless construction, an invisible threshold was finally crossed. The project ceased to be a mere blueprint, a collection of cranes and blueprints. It simply became an airport. It proudly emerged as the world's first hub airport to operate with 100% new energy ground vehicles. Every tug, every service truck, every passenger bus powered by sustainable innovation. Its strategic location connected 28 surrounding cities within a 3-hour train journey, a testament to its design as something far grander than just an aviation facility. On September 25, 2019, the moment arrived. The inaugural departure saw an A380, the majestic giant of the skies, lift effortlessly from land that just 5 years prior had been nothing but open farmland. On that very same day, China's oldest airport closed its gates forever. One era concluded, ceremoniously making way for the next. From the heavens, its form is a breathtaking spectacle, a golden starfish sprawling across the landscape, or perhaps the graceful outline of an alien spacecraft. Both descriptions, in their own way, capture its profound, almost otherworldly presence. Not long ago, this marvel was a chaotic symphony of scaffolding and complex stress data. Now it stands in quiet, undeniable beauty, a testament to human ingenuity, a structure whose profound elegance defies simple explanation.